Hey guys, all right. So I just want to do a little bit of a motivational speech before I get started on this lesson. I've been so proud of a lot of you guys that have been on top of everything and getting your work done. And I've been proud of you guys that have been emailing me and just admitting that it's been hard to be motivated and hard to get things done. I get it. It's been hard to motivate myself too, but it's my job, so I kind of have to do it because it's my job. So, I mean, that's the motivating factor for me. But, it's your future that's at stake here, guys. So, you guys have to be in charge of that and motivate yourselves. And I know that can be really hard, especially at home where there's so many distractions and so many things to get us off task. But you just got to hang in there, guys. Do the best that you can and just keep going for it and keep doing your best and asking for help whenever you need help, okay? I know it's hard to stay motivated, but you guys have to be in charge of that and just motivate yourselves. Even when you're dragging your feet, just do it. You'll be glad that you did, okay? So just hang in there. We're all not liking this, and it's just something that we got to do until we can go back to normal. If that will happen, I don't know, but I'm hoping it does because I do want to get to know you guys and see your faces in person. That would be amazing. All right, so 8.1 square root functions. Now you're going to know how to graph these. Graph and describe transformations of the square root function y equals the square root of x. Y equals the square root of x. Let me get my highlighters. They're way over there. Is the parent function. So you know how we've had parent functions with like parabolas? Well, now you're going to see parent functions for a bunch of different functions, and they're all treated the same way. You're going to see similarities when we shift left, right, up, or down. You're going to recognize those things and realize, hey, I apply basically vertex form to any function as long as I know the parent and I know how to write it in that vertex form, air quotes there, okay? We're also going to interpret key features of a graph that models the relationship between two quantities. Okay, so basically word problems. But I mean, what's the point of doing math if we don't know how it applies to something real? And that's kind of the point there. So we have to know how it applies. Otherwise, we're just doing it just to do math. Yeah, right. Okay, so it says the whole speed h in knots of a boat is given by the function h of x equals 1.34 square root of x. I'm going to box that. Where x is the length of the boat in feet at the water line. So it's the length, so x is the length of the boat in feet, okay? And over to the right, under academic vocabulary, it talks about what the hull of the boat is. The hull of the boat is the body of a boat. It is measured from the front of the boat, which is called the bow, to the back of the boat, which is called the stern. The whole speed formula is derived by analyzing wavelengths as the boat displaces water as it moves. So there's a lot of math involved with coming up with that formula to figure out how fast the whole speed is. Okay, so the whole speed function is a transformation of the parent square root function, and that is f of x equals the square root of x. Like I said up here, same thing. Y and f of x are interchangeable. Normal notation, function notation. So this is my parent function. I'm just writing it in there so I could see it. It sticks out at me when I look at these notes, and that's important. It says graph h and f on the same axes. How do these graphs compare to each other? Well, the only way that we know how to graph a square root function for right now is with the good old-fashioned t-chart. So I'm going to stick with my color codes. I'll use h of x in blue and the parent function in that green color. So we'll start with h of x over here. Actually, no, we'll put h of x over here. Because if I do it different the way I have it written down on my notes, I'm going to screw it up. I'm not a super visual learner. Like, I'm visual as far as steps go, but when it comes to the way things are laid out, it's got to be exact. All right, so let's start with the parent function. So x and y. Remember, f of x is the same as y, just function notation. Now, because we have a square root, I don't want to deal with any imaginary numbers. So what's the lowest number I can go here? Well, if I don't want any negatives, that means I can't go lower than a 0. So 0 is the lowest I can go. And since I'm taking a square root, I want to plug in numbers that are strategic. I want to plug in numbers that I can take the square root of. Like I can take the square root of 1, I can take the square root of 4, and what's another one I could take the square root of? The next one would be 9. Okay, so I'm being strategic here because when you're plugging in numbers for x, they could be whatever you want, whatever you're allowed to plug into that function. And since we don't want imaginaries, I'm only allowed to go as low as 0. Okay, when I plug in a 0, the square root of 0 is 0. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Easy peasy lemon squeezy. All right, so I have the point 0, 0, 1, 1, 4, 2, and 9, 1, 2, 3. Okay. And I could keep plugging in x values if I wanted to. I could go higher and higher and higher all the way to infinity on the positive side. Okay, so there is my f of x. I know it's color-coded, but I feel like I need to label it because it just seems more proper that way. All right, h of x now. Let's see what this one looks like. So let's do a little t-chart. And let's plug in the same numbers since I know that I could take those square roots. So 0, 1, 4, and 9. Okay, so if I plug in a 0, the square root of 0 is 0. 0 times anything is 0. So that's still the point 0, 0. When I plug in a 1, the square root of 1 is 1. 1 times 1.34 is still 1.34. Because when we multiply by 1, nothing changes. When we multiply by the square root of 4, well, square root of 4 is a 2. So then I'll have 2 times 1.34. 1.34. And I get 2.68. And then when I plug in a 9, the square root of 9 is 3, and then I'll have 3 times 1.34. 4.02. So when we graph these, obviously it's an estimate. It's not going to be exact because I have decimals there, but that's okay. A graph is an estimate anyway. It's not going to be perfect. All right, so 0, 0. 1, 1.34 would be a little bit less than the halfway mark. 4, 2.68, so 2, oops, I went too low on this one. Sorry, 1.34. I only went to 0.34, so 1.34 would be about right here. I cross out that point. And then 4, 2.68, that's a little bit more than halfway, so I'll go a little bit higher than the halfway mark, eyeballing it. And then 9, just right above 4. So like sitting on top of that line. So I see that it is going like that to positive infinity. Okay, so it's sitting up a little bit higher. So how do these graphs compare? Well, the blue one, the h of x one, is up a little bit higher than the parent function. Well, what's making it do that? Well, the only difference is this one has a 1 out front of the radical because when there's no number, you assume it to be a 1. And this one has the 1.34. So you know how parabolas have vertical stretches and compressions, the shrinks? Well, these have the same thing. So 1.34, since it's taller, it's stretched it out from the parent function. So we could say that h is a vertical stretch by a factor of, since it's being multiplied by 1.34 of the parent function of f of x. Okay. All right. So letter B, it says, what are the domain and range of f? So I hope domain and range is getting a little bit better. I saw some comments on that assignment, the IXL assignment, and a lot of you were saying how easy it was. So what are the domain and range of f? So that's just the parent function. It says to write your answers as inequalities. So I'm going to color code it. So light blue for inequalities, orange for set notation. You don't have to use the same colors as me, but it's fun. And then this dark purple for interval notation. Okay, so I'm going to start with inequality notation. So the domain and then the range. So D for domain, R for range. So for the green function, for domain is a set of x's, and the lowest x that we're using is right there at the origin, so the x value there is a 0. Okay, but then it goes to positive infinity. So that means that as an inequality, x can be anything greater than or equal to 0. Now for the y's, so we're looking at the y-axis now. What y values is it using? Well, it's starting at 0. It's not going any lower than 0, but the arrow means it's going to infinity, so it's going to go up and over and up and over and up and over. So it's using everything on the positive y side. So y is also greater than or equal to 0. Okay. Once we have that established, the other notations are pretty easy because it's still the same domain and range, just represented in a different way. So in set notation, that's where we use the squiggly line brackets. So we got to put x and the vertical bar for such that, and then you just put the inequality, x greater than or equal to 0. So it's basically a fancy way to use inequality notation. And then for the range has to do with y, so y such that y is greater than or equal to 0. And then in interval notation. So interval notation, well, we can equal the 0, so we get to use a square bracket on 0. But greater than or equal to 0 means we're going to positive infinity. We can't equal infinity, so we have to use parentheses on that. Same with the y. We're starting at 0, but we can equal 0. And then we're going to positive infinity, so parentheses on that. So the notations that you guys are going to see the most throughout Math 3 are mostly going to be these two. You're not going to see set notation a whole lot except for when you are asked to write it. If you are going further in math, like going towards an engineering or math degree, you are going to see more set notation. Okay? And just because you aren't in Enhanced Math 3 doesn't mean that you might not go on that pathway. You could still go that way. I didn't take calculus in high school. I took it slow. So everyone works at different paces. So don't think that you're completely out of the running if you're not in those enhanced classes. That doesn't mean you can't get there. You can still get there. Okay? Just want to point that out. We can change our minds. Letter C, given that x represents the length of the boat, should the domain of h of x be more restricted than f of x? Can you determine the domain precisely? Explain your reasoning. Well, remember x, we underlined it up here. X is the length of the boat in feet. So if this represents the length of the boat in feet, the lowest it can go is 0, but it can go to positive infinity. Can a boat be infinitely long? No. So there would be a domain restriction because you're not going to have a boat that's infinite in length. It's just not going to happen. There's no way. It's not possible. So we can say the length of a boat isn't, I'm just going to put the infinity symbol, isn't infinity. We can't really determine the max length of a boat. Now, if we knew more about boats, we might be able to, but because especially me, I know nothing about boats except for I've been on a cruise, I've been in a deep sea fishing boat, and that's it. Like I have no experience on a boat. I don't know anything about the lengths of a boat. So unless we know, we're not going to know. All right, explain how to write the square root of x using rational exponents. Now, this is a big thing. This is something that you'll see even on the state test, if we even do it this year. I don't know, but I still got to prepare you for it because what if we do? So when we have a square root, there's a couple things that we have to remember. Normally, this is a square root because there's no number inside. We assume it to be a 2. That's called the index, okay? And when we rewrite this using rational exponents, that just means that we are writing it as an exponent instead of as a radical. So it's x because it's to the first power, so 1/2 because the index is 2. The denominator in a fractional exponent tells you what kind of root it is. And this is something that you've seen before in Math 2, and you work with it more in math 2, so you get used to the idea. But it's probably been a little while, excuse me, because I just finished teaching that a couple weeks ago in my math 2 class. So for example, what would be the cubed root of x squared written as a rational exponent? Well, it would be x to the, well, x is to the second power. The root is a cubed root, so x to the 2/3 power. Whoa! It's really easy. You just have to get the hang of it and learn those definitions and stuff. That's all. Write h of x using rational exponents. Okay, so h of x equals 1.34 square root of x, and now they want us to write it using rational exponents. So that means we have to change that square root of x to a fractional power. Remember, this is a square root, and x is to the first power. So we could rewrite this as h of x equals 1.34 times x to the 1/2 power. That's it. So anytime you see a fractional exponent on a variable, it's also a radical. The denominator of that fraction tells you what kind of a radical it is. Square root, cube root, fourth root, whatever root. Okay? Turn page. All right, explain how you could use transformations of the graph of f of x equals square root of x to graph g of x equals 2 square root of x. Well, we know that this is the parent function. And this one is the parent function, but it has been altered. It has a 2 out front. So that means it's going to be vertically stretched by a factor of 2. So we know that this is a vertical stretch now because we know how that behaves on the graph. So remember how when we came up with the table of values for h of x, we had to take the square root of the number and then multiply it times 1.34? Well, we would take the square root of the number and then multiply it by 2. So all we'd have to do is multiply the y values by 2. Super easy. Okay. So that's how you perform a vertical stretch. Just multiply the y's by a value of 2. Super easy. Easy peasy lemon squeezy. Consider the functions f of x equals square root of x, parent function, and g of x equals the square root of 2x. Write g of x as a product in the form of a square root of x. So anytime you have a number in front of the x underneath the radical, you can separate it. So that's why they want us to rewrite this. They want us to pull out that square root of 2 out front. Square root of 2 times square root of x still means this. It's still the square root of 2x because they're inside numbers. We multiply them together. But now you can see that this is a number. It's a decimal, the square root of 2. We could type that into our calculator and we'll get a decimal that goes on forever. But it's still a constant. So that means that this is still a vertical stretch. Okay. Letter B, explain how you could use transformations of the graph of f of x equals square root of x to graph g of x equals square root of 2x. Well, just like up here, you know how we had to multiply the y values by 2? Well, for this one, we would just have to multiply the y values by the square root of 2. So multiply the y values by the square root of 2. How does the graph of g of x equals the square root of x minus 3 compare to the graph of f of x equals the square root of x? Now we're getting down to it. So, well, what would this mean if it were a parabola? Which way would we shift that? Any guesses? I wonder if you guys are guessing to the right. And you would be right if you guessed that. So yes, that is a horizontal shift. Numbers outside of the radical will be a vertical shift. Okay, so number 5, let's see what that looks like. It says sketch G and F from item 4 on the same axes below. So I'll keep, f of x, the parent function, in green like I did on the last page. And we know we have the points 0, 0, 1, 1, 4, 2, and then 9, 1, 2, 3. So there's our parent function. Okay, and let me use a different blue. I'll use this blue for g of x. So it's the same thing, but shifted to the right 3. So 1, 2, 3. That means everything gets shifted over 3. 1, 2, 3. 1, 2, 3. And then that one's off my graph, so that's okay. Oh, I totally missed that point. Oh, that's okay. All right, see how easy that is? Okay, what are the domain and range of G? Okay, well, domain is the set of x values, and notice how it didn't say how to write the domain and range, so I'm just going to use inequalities for my D and R. Okay, well, for G, that's this blue graph, the lowest x value it's using is a 3, but then it uses everything to the right of 3. So x greater than or equal to 3, because I do have a point at 3, okay? And then the range, well, the lowest y value we're using, well, we're not going on the negative side, so y can be at 0 or above 0. So the domain x greater than or equal to 3, the range y greater than or equal to 0. Number 7, oh, I don't want to do those. Go on to the next page. All right, we're not going to do everything on this back page, so we are almost done, okay? So it says multiple transformations can be applied to basic functions to create a new function. Transformations might include translations, reflections, stretching, or shrinking. If we're stretching, we're multiplying by numbers bigger than 1. If we're shrinking, the number is smaller than 1, like a decimal, okay? And obviously, if it's a reflection, that means that we're multiplying by a negative and it reflects across the x-axis. Okay, so number 9, it says to describe the transformations of f of x equals the square root of x that result in the functions listed below. Well, the negative out front means that it's getting flipped across the x-axis. So this is a reflection. So reflect across x-axis. Okay, and then there's another transformation in there. There's a plus 2 this time. Well, if it was a minus a number, it meant to go to the right. So plus a number means it must mean to go to the left 2 units. Okay. And then letter B. This one has a transformation on the inside. Remember, to the left means plus a number. So to the right would mean minus a number. So we're going to the right 3 units. And this one on the outside, that plus 4, it's outside the radical. So it's just like a parabola. This would be, it's positive, so go up 4 units. So it's super easy. So now you don't have to do a table every time you have to graph these. You just have to remember the parent function and shift it according to whatever its transformations are. All right, we're going to sketch the graph of each function in item 9 as well as the parent function. So I'll keep the parent function in this lime green since that's what I've been doing this whole lesson. Okay, and then state the domain and range for each function. Write your answers as inequalities in set notation and in interval notation. We're going to write our answers in interval notation for this one. We did it in set or inequality notation the first time, so we'll do it interval notation this time. All right, so starting with the parent function. So 0, 0, 1, 1, 4, 2, 9, 1, 2, 3. It's funny how after you just do it a couple of times, you just start memorizing stuff by not even really trying hard. Oh, let me label that. So that is f of x. And let's do g of x. Oh, since I have this blue right here, I'll do it in blue. G of x is in blue. So it was shifted to the left 2. So I'm going to shift the first point there to the left 2 units because that's where it's going to land. But then it's getting flipped over the x-axis. Now because that's on the x-axis, that means it's still going to be on the x-axis. So let's shift this one to the left 2, 1, 2, and now flip it over to the other side of the x-axis. And shift this one to the left 2, and flip it over to the other side of the x-axis. And shift this one left 2, and flip it over the x-axis. So it's 1, 2, 3 on this side, so 1, 2, 3 on the other side. So there it is, reflected, and there is g of x. I think it's kind of fun to do these. I know a lot of you probably still hate graphing, but you have a lot of it to do this unit, so you're just going to have to suck it up, Buttercup, and get her done, because the more you do it, the more you're going to understand it, and the more you're going to like it. Promise, but you got to do it. You got to give it a chance. All right, so h of x, it's the parent function, but shifted to the right 3, so 1, 2, 3, and then up 4. 1, 2, 3, 4. Take the next point to the right 3, 1, 2, 3, and up 4. 1, 2, 3, 4. And then do one more point, this one, to the right 3, 1, 2, 3, up 1, 2, 3, 4. And there's h of x. Pretty cool. And it's nice to color code these. If you keep it all the same color, it's kind of boring, guys. Be colorful. All right, and number 11, it says, without graphing, determine the domain and range of the function. So what's going to help us is to know that this is shifted to the left 5 units and down 1 unit. So I know it says without graphing, but we should at least see where the first point is, because then that tells us how high or how low it's going to go. So I know it says without graphing, but let's just go ahead and do it. If we're going to the left 5 from 0, 0, 1, 2, 3, 4, 5, and then down 1, oops, we're over here. Okay, at the point -5, -1. And I'm just going to fake it. It's just going to go like that. Okay, so it's kind of easy to see now what the domain and range are going to be. Let's write it. Oh, I forgot to write the domains and ranges up here. So we'll go back to that. So the domain and range of this one, well, the lowest x it's using is -5. So x has to be greater than or equal to -5. And the lowest y value it's using, well, it's not going any lower than a -1. So y has to be greater than or equal to -1. Okay, and I use inequality notation on that one. For the other ones, I'm going to use interval notation. So I'm color coding it. So for domain and range for g of x, well, the lowest x that g of x is using is all the way down to a -2. So I can go from -2 to +infinity. The range, well, the highest y value that I'm using for g of x is at a y value of 0. I'm not crossing that x-axis. I'm just sitting on it. But then everything else below it is okay. So I'm going from 0 to -infinity this time. F of x, we know. The lowest it goes is 0, so 0 to infinity for the x and 0 to infinity for the y. We went over that a couple times already. And then h of x, domain and range. Well, the lowest x that we're using is that's what, a 3? I don't know why I'm so shaky. So from 3 to infinity. And the lowest y value we're using is a 4 right here. So 4 to infinity. And there's our domains and ranges for each of those 3 functions. Okay. All right. And I believe that is it. If I remember correctly. Just want to check real quick. Yep, that's it. Your homework will be posted. See you soon.